So today we're going to dive into this really cool AI technique called self-refine. And it's all about something pretty fundamental, something we humans do literally all the time, looking at our own work, critiquing it, and then making it better. I mean, we've all been there, right? You fire off an email, you write a document, you hit send, and then that immediate feeling of, oh, I wish I could just pull that back and tweak it. That first attempt, it's rarely our best stuff. It's just part of how we create things. Just think about the difference between a rough draft and a polished version. On the left, you've got this blunt, kind of demanding message, but with a little refinement, it becomes polite, professional, and honestly way more likely to get you what you want. It's the same request, just better. That's the core idea here. And here's the thing, it's not just a human problem. Even the most powerful large language models, the ones that seem to get everything right, they don't always nail it on the first try either. Their first pass can almost always be improved, whether it's making code more efficient or just making a response more helpful. So what's the solution? How do you actually get an AI to, pause, take a step back, and revise its own work? Well, that's where this really clever idea comes into play. You essentially give the model its own inner critic. The crucial thing to get here is that self-refine isn't about using multiple different AIs. It's a framework where one single model does everything. It's the author, it's the critic, and it's the editor, all in one. It writes something, gives itself feedback on what it wrote, and then uses that feedback to make it better. And this is what makes the whole approach so incredibly efficient. You don't need a second, specialized AI to act as a critic. You don't need tons of new training data or expensive humans in the loop. You just use the same powerful model you already have for every single step. It's a really elegant solution. Okay, so how does this whole thing actually work? What's going on under the hood? Well, it all comes down to this simple but really powerful three-step loop. So it all starts with step 1, generate. The model spits out its first draft. Then you move to step 2, feedback. Here, you prompt the same exact model to look at its output and act like a critic. And the key is that the feedback has to be specific, actionable. Then in step 3, refine, the model takes its own advice and rewrites the original output. All right, that's the theory, but what does this look like in practice? The paper gives this absolutely perfect example using self-refine to make a snippet of computer code way more efficient. So first up, the generate step. The AI is asked to write some code to add up numbers. It produces this function here on the left. Now, look, this code works. It'll give you the right answer, but it's really slow. It's using what we call brute force, just looping through and adding every single number one by one. Kind of clunky. Now, for the magic, the feedback step. The same AI is asked to critique its own code. And check this out. It correctly identifies the problem. It says, this code is slow as it uses brute force. And it doesn't stop there. It actually suggests the exact, much better solution. Use a well-known mathematical formula instead. That is fantastic, actionable feedback. And finally, the refine step. The model takes its own advice and rewrites the code. And boom, look at the difference. It goes from that clunky multi-line loop to this elegant, super efficient one-liner. For big numbers, this new version is literally thousands of times faster. A huge improvement. And you know what the best part is? This isn't a one-and-done deal. You can run this whole generate, feedback, refine loop over and over again. And with each cycle, the output has the potential to get even better. All right, so that code example is pretty mind-blowing. But does this technique actually deliver the goods across a bunch of different tasks? Well, the researchers really put it through its paces to find out. And to put it simply, the results are just wow. We're talking about some seriously dramatic improvements here. I mean, check this out. For one particularly tough task, just applying self-refine to GPT-4 resulted in a massive 56.9% absolute improvement. That's not a small tweak. That is a giant leap in performance, just from letting the model think twice. Let's look at another one, generating dialogue. The researchers asked people which version they preferred, the original or the refined one. The base model's answers were picked about a quarter of the time, but after a round of self-refine, that number jumped to almost 75%. People preferred the refined version 3-to-1. That's huge. And this wasn't just a fluke. As you can see from this table, the pattern is consistent. It works across different models, GPT 3.5, ChatGPT, GPT-4, and across a whole bunch of different jobs. from creative writing tasks to making code easier to read. Self-Refine just keeps delivering these big double-digit gains. So, okay, the numbers are impressive. We've seen what it is, how it works, and that it's super effective. But let's zoom out for a second. Why does this really matter? What's the bigger picture here? Well, the advantages are just massive. You're getting much better results without having to do any costly and time-consuming retraining of the model. It's super efficient because you're just using one AI and you don't need any special data or a human babysitting it. It's this powerful, flexible tool that basically unlocks the potential that's already sitting there inside these models. And this quote from the paper itself just nails it. The top-tier models, like GPT-4, have all this hidden capability. They're actually smarter than their first answer might suggest. Self-Refine is basically the key that unlocks that hidden potential. At the end of the day, what we're looking at here is more than just a clever trick to get better chatbot answers. This feels like a fundamental shift. It's a really big step towards creating AIs that don't just generate things, but can actually reason about what they've created and make it better, all on their own. And that really just leaves us with this one big, fascinating question to think about. As we get better and better at this, what new things become possible? What happens when our most powerful tools learn not just answer our questions, but to question their own answers?